LCMs and LCDs the same? All right, this is the big question we're going to ask today. So I'm asking you, what do you think? How many of you, by raise of hands, think that LCM, first of all, let's do this. One of the questions on your page here, what is an LCM? What is an LCM? Least common multiple, write that down. Least common multiple. Now if I ever ask you guys a question that's in your book here, and you have to write the answer, and you want me to write it on the board, say, Brother, should we write that answer down on the board? Okay? You want me to write least common multiple on the board, or are you good? We good? I can write it. Don't ever be afraid. Dude, I like this shirt. That is some serious Hawaii vibe. Okay. Did I tell you guys I love Hawaii? Yes or no? No?
No.
No. Okay. I'm telling you now. I live in Hawaii at least almost 2 months of every year. So when yeah, it's a pretty good life. I own a company and I can run it remotely. So when I'm not teaching here, I mean, every April I head over for the winter swell on the North Shore, and I love Hawaii. I've been surfing since I was a little kid. I was born and raised in San Diego. Who surfs? Anybody surfing here? Yeah. Yeah. Yeah, wake surfing's cool. Yeah. Not as cool as ocean surfing, but you know. Hi, amen, brother. I would do it, but you know, I don't have to. That's terrible. I love Hawaii. Who's been to Hawaii in here? If you ever talk about Hawaii, it's like laughing at my jokes. I love you. So, you wear a Hawaiian shirt, I'm loving you. You know, I'm like, all right, man. That's good. Okay. So LCM stands for least common multiple. What does LCD stand for? Least common denominator. Denominator, yeah. So write that down. Denominator. Okay? What's a denominator? It's part of a fraction. Which part? The bottom. Yep. The bottom. I'm so uncomfortable with you pointing at me all the time, Grace.
You wanted it.
I know. When you miss class and have to miss class, we have YouTube videos. That's why Grace is always here. I probably shared this with you last time, but it's a great thing when you have to miss class to be able to look up these videos. So we make them for you. Okay. So I'm going to return the question at the beginning here. Are LCMs and LCDs the same? How many people say they are the same? Raise your hand. How many people say they are different? Raise your hand. Okay, listen. All right. Straight up. Pause for a second. Again, I like you guys. We're going to do this. Okay. All right. Here's what's up. How many people think that LCMs and LCDs are the same? 0. How many people then think they are different? Everyone. Okay. So it's 30-0. Okay. Let's do a couple of things. What is the LCM of 4 and 6? What's the LCM of 4 and 6? 2. Okay, I like this answer. 2. I love this answer. It's wrong. But I love it. I love it. Now I'm going to tell you why I love it in a minute, okay? What's another answer? What do you think? What do you think? 1, okay? I love this answer. And it's wrong. Okay? And I love wrong answers, okay? All right. What's another one, maybe? 12. Say it louder. Say it. 12. 12 is correct. 12 is correct. Good job. Okay? All right. Let's go back a couple of pages from our lecture last time, all right? Math is a progression of knowledge. You've probably heard people say before, math builds on itself. One lesson builds on the next, yeah? I always find that kind of funny when people say, math builds on itself, as if other subjects don't. Every subject builds on itself. Everything's a progression, okay? Whoa. And, oh, look at that. Oh, there's Donald Trump. Trump notches lost. Never mind. Okay. I don't know why that feed came up. Oh, great. Here we go. This computer has been so spastic. Ooh. It's kind of got a mind of its own. All right. Factor and multiple. Okay? What's a multiple? Well, let's go back to this. I just asked you, what is their LCM? Least common multiple. All right, least common multiple. So a multiple is not a factor. So define multiple, right? It's a times table. It's something that comes out of our number through multiplication. So go ahead and tell me the multiples of 4. Help me. 4, 8, 12, 16, keep going. 20, 24, 28, 32, and one more. 36. Cool. All right, how about the multiples of 6? 6, 12, 18, 24, 30, 36, one more. 42. Okay, good enough. All right? So, by definition, this is one of the best names I've ever seen. It's just, what's your name? Belt buckle girl, I love you. What's your name?
Whitney.
Whitney, okay? Least common multiple reminds me of Whitney, okay? It reads as it's dressed, okay? She says she wants to ride horses. Look at her for a minute. Look at her boots, look at her buckle, look at her shirt, look at her pants. She is a horse girl, 100%, okay? Okay, least common multiple. Least, lowest, common, same, multiple, times table. Between these two numbers, what's the lowest number that's a times table of theirs they share in common? 12. Ding, ding, ding. Okay? 12 is correct. So what the fetch is 2? And what's 1? How did you come up with that? They're factors. Yeah, they're factors. Okay? Very good. Very good. They're not multiples, they're factors. Factors are things that go into our number. Okay? So what you're doing then is you're saying, hey, LCF, least common factor, or least common fetcher. Okay? I don't own those. I might need those. I do. Okay? All right, let's go to our page that we're taking notes on then. Okay? So, all right. Okay, so what is the LCM of 4 and 6? The answer is 12. So now, let's look at this. If I have 1/4, and 5, 6, and I ask you, what is their least common denominator? Do you know what the answer is? It's 12. So we return to our question, 30 to 0. Are they the same or not? Are they the same or not?
Yes.
They are.
They're the same. They're the same. So we got a lot of answers wrong. Let's talk about that for a second, right? While you're writing down that they are the same. And then you can write down that the LCD of these does equal 12. Okay? Before we talk about wrong answers, I just want to show you something interesting here. If I add these two fractions, can I say that 1 plus 5 is 6 and 4 plus 6 is 10? Is that correct?
No.
I can't do that. I can't do that. All right? That is not correct. These have to be the same in order for me to add or subtract fractions. Okay? Okay. So there's a reason why we find LCMs and, because LCMs are LCDs, and there's a reason we find LCDs because they're the only way we can add and subtract fractions. A little later today, we're going to talk about Karate Kid. Oh yeah. We're going to talk about Karate Kid briefly, okay? But right now, I want to talk a little bit about the concept of progression, okay? In the gospel, it is known as the eternal plan, or the plan of eternal what? Is it perfection or progression?
Progression.
Which one?
Progression.
Progression. But it's interesting because we talk about being perfect in this church, okay? But I really want to help you guys with something right now. I really want to help you with something. I truly believe that the greatest pandemic that we have faced in the past decade is not COVID, but anxiety and depression. I think that's the greatest pandemic in the world. I think it's taken more lives. I think it has made people with, have more heart disease and more physical and mental health failures than the pandemic ever did or ever will. Anxiety and depression. Okay? So, something interesting about anxiety and depression. What do you think causes anxiety and depression in your lives? Any answers? Any? Stress? Okay. What else? Schoolwork. Okay. What's that? Tests. Okay. Anything else? Yeah.
Lack of confidence in yourself.
Okay, I like that. So one of the things that I would say that causes a lot of anxiety for us and depression is the feeling that we are not good enough. We are not enough. And that is tied to a vision of perfection rather than progression. Perfection is that we go from 0 to 100, like that. Progression is that we are good with a growth mentality that if we just grow a little bit better as we go along, that we can take joy in that. That is the plan. That's our Heavenly Father's plan. He didn't send us here to be perfect. He sent us here to make progress. That's it. So look at this. When we get this stuff wrong, I'm stoked. And when we do things wrong in this life, he's stoked. And you're like, Brother Rich, that's false doctrine. But he's only stoked if we're willing to push ourselves to the next step. Because he understood before we came here that mistakes are an inevitable step in the learning process. Right from the get-go, he provided a savior and an atonement for us. So making mistakes is part of life. So one of the things that causes anxiety and depression is the feeling that you have to be flawless, that any flaws cannot be, a part of you and that kind of a thing. And I want to share something else with you. What do you think one of the biggest sources of that kind of way of thinking of, we must be flawless? What do you think one of the biggest sources of this need to be flawless, where do you think that comes from in your world right now? Social media. You nailed it. Social media. Two of the biggest sources of anxiety and depression in your generation, one was the pandemic. We sent all you kids home from school. You didn't get to socialize. All the pandemic was scary and this and that, masks, everything, people fighting about it, all this kind of crap. That's one. The other one, you ready for this? Another source of anxiety and depression for you? Your parents. But it wasn't their fault. You ready for this? But it is their fault. You're like, yeah, my parents, man, they screwed me up. Okay, I ain't talking about that. Everybody thinks their parents screwed them up some way or another. Okay, listen. I'm talking about the fact that your parents never had cell phones when they were kids. And they never had social media. So when Christmas time came around, Mom and I, what should we get Johnny and Susie for Christmas? I know, let's get them an iPhone freaking 15. And you're like, that's a good idea, dear. Here you go. And then we hand you a phone. We never used them. And we never did social media. So we didn't even teach you how to govern them. We just handed them to you from a little age. And all of a sudden, you got all this crap going on in your life. It is your responsibility to be better than that. You will be the generation that inoculates the biggest pandemic, the pandemic of anxiety and depression. You don't need a shot for that one. They need you. The gospel and Jesus Christ are going to be great sources of that. But you will be the generation that overcomes anxiety and depression because you have to. And you've got to be able to teach your kids how to handle social media because social media isn't all bad or all good. But can I share something with you really fascinating? You take a kid that has what we call teenage angst. Do you know what teenage angst is? A-N-G-S-T. It's a cool word. You know what it is? What are teenagers typically? I know you guys, many of you are teenagers too, but what are teenagers? What do you think when you think of a teenager? Stubborn? Yeah, maybe. What? Pimples? Testosterone. Okay, so chemicals, stubborn, moody? Yeah? Rebellious? Sometimes kind of negative at times, like they see things through a dark, a little bit, yeah, go ahead. Impulsive, okay. So here's the deal. You take a kid with teenage angst who's had the worst day. They're super depressed that day. Everything's gone wrong. And guess what they do? They get on their phone and look at social media at people who are doing what right now? Having the best day of their lives. Oh, that's a recipe for really feeling crappy about yourself. That's dumb. That's just dumb. When you feel crappy, don't get on social media. Tell me something right now. Could you Could you create a story on Insta or anything that makes you look like you are killing it and it's the best day of your life? Yes or no? And could you do the opposite and make it look like it's the worst day of your life? Yes or no?
Yes.
So is social media an accurate depiction of you? No. And it ain't an accurate depiction of any of the other idiots you're looking at either. You know what I mean? Including me and everybody else. You know what I'm saying? I'm an idiot, you're an idiot, we're all, it's like, no, that's not reality. So you gotta fight these battles, okay? You gotta win them. So what does that have to do with math? And why do we talk about that in this class? We're not gonna talk about, we're gonna do a lot of math in here. A lot. Look at the size of this book. We're gonna get through this whole thing in one semester. There's no worries. If you're like, why is he talking about this crap? Why is he talking about the Karate Kid? We better just do math. Say, okay, Homer. We're gonna do a lot of math. But here's the deal. I need you to understand in this class, it's okay to be wrong. I love when you're wrong, because wrong is the first step to making progress. If you're willing to learn and to get better, right? And that's the goal. That's the goal. And when you understand in your own lives, I wish somebody would have taught me this years ago. When you understand in your own life that progress is the whole purpose, then you really lose a lot of anxiety. You're like, hey, I can make progress. I don't need to be perfect. Okay? All right, so we've determined that LCDs and LCMs are the same. So here we go. Is there such a thing as an LCF? Raise your hand if you think there is such a thing as an LCF. Yes? How many people say no? Anybody say no? Tempting fate. These two are tempting fate. Okay? We got 2 no's and 28 yeses. All right? What is the LCF, least common factor of 4 and 6? What's their LCF? Say it loud. 2. It's not 2. Close. What's the LCF of any set of numbers? Think about it. What is the lowest common factor? If we were to, what number is this divisible by? That's the lowest number. And the lowest number that's divisible by? 1. See? So how about these 3 numbers? What's their lowest common factor they're divisible by? 1. How about 2 and 5? 1. How about 105,000? So what is the LCF of any set of numbers? 1. It's 1. So it's kind of a dumb question, isn't it? Because the answer is always 1. So is there such a thing as an LCF? Not in any math book I've ever seen. Okay? It's not a mathematical concept because it's just 1. So the answer is no. You two, way to go out on a limb, way to send it. Okay? The answer is no. There's not such a mathematical concept as the least common factor. We cool? Okay, let's move on. I told you last time in class, I believe I told you, I hope I did. If I didn't, it's okay. I'm going to say it about 2 or 3 times over the next week, and then I'm never going to tell you again. I'm going to rely on you to do it for yourselves. But your books were printed in black and white to save you a lot of money. But every time you see a red box, you want to put a big star by it. Because at the end of the semester, or not the end of the semester, at the end of each chapter, we're going to do a review to prepare for the test. And all those big stars will help you know, hey, that's something I got to know for the test. That's something I got to know for the test. So go ahead and put big stars by that because yours don't show in red, mine do, okay? But to give you some kind of a clue that, since they're not in red, I mean, if you have a highlighter pen, you want to highlight them, if you want to put a star by them, but just mark them in some way, shape, or form. There are 3 methods by which we can find LCMs and LCDs. The first method is the illustrious in your head method, okay? Which means sometimes you look at a problem and you know the answer in your head. If I write on the board right now, 2 and 3. What is their LCM? The first times table, first multiple they share in common. 6. Look at you. You did it in your head, okay? Smaller numbers, a lot of times we can do that, okay? Some of you didn't get it. And you're like, oh man, I'm not as smart as the rest of the class. Nope, okay? Doing stuff in your head is not the goal of math. We want to have systems that we can use that will always work. Our head will fail us, okay? Right now, if you ask Brother Rich, what is the LCM of 40 and 48? I don't fetch a know, okay? I can't do that in my head. Can you? Probably not, okay? Our head's going to fail us eventually. So the in your head method, we're not going to use that very often. Multiple method. The multiple method is what we just did right here. Notice the 2 steps. It says multiple method. First, write out the multiples, times tables of each number. That's what we did. We wrote out our 4s and our 6s until step 2, we found the first one they shared in common. We circle that. We now know the LCM is 12. So right here where we have 4 and 6, you should have that written down right there. And you should circle the 12s. But now I want you to do the same with 24 and 30. I'll do it with you though. Okay? So go ahead and write down the 4 and 6 thing, and I'll get us prepped here for 24 and 30. And we'll go from there. Gotta do that. Okay. 24 and 30. All right, so this is a little bit tougher, the multiple method. Multiple method, the in your head method fails you because your heads don't have all this information that you need. The multiple method was really easy for 4 and 6, but you know, we're lucky if we know our 1s through 12s times tables, but 24s and 30s, we're going to need some help with the calculator probably. So 24 times 2 is what? 48. How about times 3? 72. How about times 4? 96. And times 5? And times 6, whatever. Anyways, next one, 144, right? You guys know the next one? We're going to go for a little bit here. 168. How about the next one? 192. Okay. And 216. And then 240. Okay, how about 30s? How about 30s? This one's a little easier, right? 30, 60, 90, 120, 150, 180, 210, 240, we're done. Okay. What's their least common multiple? It's 120. Yeah, you can visually see that. That's the multiple method. Do they share another common multiple? 240. Okay, let's go back to 4 and 6. Do they share another common multiple? 24. What else? 36. Okay, and it'll keep going. There'll be more and more and more. You want to know something really fascinating? The lowest common multiple is 12. The second common multiple, second is 2. 2 times 12 is the third common multiple, 3 times 12 is 36, okay? Same thing up here. If you want to know the second common multiple, multiply 120 by 2. What's 120 times 2? It's 240. Second common multiple, okay? But we're only interested really in the least common multiple, right? So let's go to the next set of questions here. And it says, do they share more multiples in common than 1? Yes or no? Yeah, we just showed that. We circled them. So yes, absolutely. Are all common multiples LCMs? No, there's only one that's the least. Okay? What is the weakness of this method, the multiple method? What do you think the weakness is? Yeah?
It can be long and drawn out.
Long and drawn out. I'm going to help this be really succinct for you. If you want to write this answer down, you can, or you can write your own. When the numbers are big, it sucks. That's it. If you don't like the word sucks, come up with something else. When the numbers are big, this method, I don't know. I got a lot of things going through my head that are highly not appropriate. So. Okay? All right, let's go to the next page. So the third method, notice, remember there was 3 methods? If we go back, it said there are 3 methods to find the LCMs. The third method was the prime factorization method. So we go to this page. This is our last page today. When we cover this, we'll be done. But we won't be done for the day, because we're going to teach you a few things out of Canvas. If we get out early, wow, it'd be like a first for me. I'm just kidding. I get the students out early, intermittently, here and there, during the semester. Prime factorization method. Okay, we got some things to do here. So, why would we not just stick with the in-your-head method? It'll fail us. And why are we not going to stick with the multiple method? Yeah, it's bigger numbers. It's really tough. We got to get calculator and sit there and multiply, 48 times 2, 48 times 3. It's just too much. So the prime factorization method is one that will always work. So what's the LCM of 4 and 6 again?
12.
It's 12, right? So we know that. So let's go ahead. I got all kinds of pens in my pockets. I can't even get the stupid finger in there. Okay. All right. So we got 4. We got 6. Our first step says that when you use the prime factorization method, we're going to prime factorize each number, okay? So to prime factorize, we learned those steps. That was our homework for Monday, due today, right? So we put an upside down V under each number, and then we're going to prime factorize each number. So tell me, what are two numbers when multiplied together that make 4? 2 and 2. Very good. Is 2 prime? Circle it. Is 2 prime? Obviously, circle it. So the answer is 2 times 2. What are two numbers when multiplied together that make 6? 2 and 3, or 3 and 2. 2 is prime, 3 is prime. We write that 2 times 3. So we have accomplished steps 1 and 2. We've prime factorized each number, and then we wrote the prime factorization in the expanded form at the bottom of each problem. So I gave you 2 rules last time, or suggestions, or whatever I said in class that we do. One is to get unplugged, and the other was occasionally I'm going to ask you to drop your pens and pencils. This is one of those times. I want you to drop your pens and pencils, because the next thing we got to learn is kind of a hurdle. It's one of these things, and you're going to see as we go through each day, you're going to be able to really trust. Brother, it's just pretty straightforward here, man. Like, you know, he's telling us stuff we need, and he's not telling us stuff we don't. So this step right here that we're about to do, you need to not have your heads down. You need to watch. This step is called the competition step. And the reason it's called the competition step is this. Listen, if I multiply 2 times 2, I get what? And 4 times 2 is what? And 8 times 3 is what? So what's the LCM of these two numbers? It's 12. 24 was a common multiple, but not the least common multiple. So if you just multiply, it makes sense. What's 4 times 6?
24.
Sometimes when you multiply your two numbers, you actually do get the least common multiple. But most of the time you don't. So to ensure that you can get the least common multiple, we have this step called the competition step. And here's what we do. I'm going to give you an example right here. If I have 2 times 2 times 2 times 3, how many 2's exist right here?
3.
How many 2's exist in this one? 3 beats 2. Okay? So 2 appeared 3 times, and here it appeared twice, so 3 beats 2. We'll tell you what happens to the winner here in a minute. 3 appears here how many times?
1.
And here how many times? So this is the winner because it appeared here more times than the others. So we're going to come over here and I'll show you what we do. How many times does 2 appear in this factorization? Twice. How many times does it appear here? Once. So the winner drops down into the answer and the other one cancels out. Okay? How many times does 3 appear here? 0. How many times does it appear here? Once. So it's the winner because it was the most times, and it comes into the answer. Now you multiply them out. 2 times 2?
4.
4 times 3?
12.
Whoa, 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 it's magic. There you go. We can use this method. Now you're like, Rich, that's a big method for just 4 and 6. All right, well, obviously 24 and 30, we're going to need a little more help with 24 and 30 than we did with 4 and 6. And we're going to have a lot bigger numbers to mess with in our homework than just 4 and 6. So we're going to take 24 and 30, and we already figured out 24 and 30. What was their LCM? It was 120. So we take 24 and we take 30. Now I want you guys to do something for me right now on your own. So you got some space in your book. So go ahead and write this down for 4 and 6. But now I want you to do 24 and 30 on your own. I want you to prime factorize them both. And then I want you to play the competition game with them to see which factors drop into the answer. Okay? And see if you can come up with 120. Because you already know what the answer is. See if you can get the right answer again. Go for it. You can pause. Yeah, you can always ask them. You guys got the attendance notice got to run? There's more than one way to prime factorize 24, right? There's lots of different numbers you can pick. What are two numbers when multiplied together make 24? 2 and 12. What's another pair?
6 and 4.
6 and 4. What's another pair? 3 and 8, right? So you could have picked any one of those and still got the right answer, right? Because this always works no matter what factors you pick. So I heard 2 and 12. Is 2 prime? Circle it. Is 12? Nope. Repeat. 2 times 6. 2. 2 times 3. 2, 3. So at the bottom of this, you should have had, no matter what numbers you picked, whether you picked 8 and 3 or 6 and 4 or whatever, you should have 2 times 2 times 2 times 3. Say woo if you got that right. Woo. Very good. 30. What are two numbers when multiplied together make 30? 3 and 10. Circle the 3, it's prime. Repeat. 2 and 5. Circle, circle. Put them in order. 2 times 3 times 5. Say woo if you got that right. All right, so now it's competition time, right? we have 2s, 3s, and 5s. How many times did 2 appear here? And here? So they're competing with each other, right? We don't add them. There's nothing up there that says 3 plus 1 makes 4 2s. We don't count it 4 times. Or we're going to get not the least common multiple, but a common multiple, right? We got to get the least common multiple, so we have to compete. So 3 times here, 1 time here. So how many times are we going to put it down here? 3 times, right? So this one is the winner. That one goes bye-bye. So we got 2 times 2 times 2. This one was interesting. You have to think for a minute. 3 appears here how many times? Once. And here? Once. So how many times do you think we counted down here? Once. Very good. So the concept is the greatest number of times it appeared in any one number is the times that you count it down in the answer. Well, it appeared once and once. It's the greatest number of times, but it was just a tie. So it's still just once. So students ask me, well, what if 2 appeared here 3 times and here 3 times? What if we had, look up here. What if we had 2 times 2 times 2? Okay? How many 2s would drop down here? 3. Still would be 3 2s. Okay, all right, good. You got that concept. All right. How many times does 5 appear here? 0. And here? Once. So we're going to count it once. Then we multiply it all out. You have a calculator. We want you to use it. You get to use it on test. 2 times 2? 4 times 2? 8 times 3? 24 times 5 is 120. Whoa, 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 it's magic. Look at that, fetchers. It's the exact same thing as the multiple method. So now, the last one I want you to do, you can find the LCM of any set of numbers. It doesn't have to just be a pair. It could be 3, it could be 4, it could be 5 or more. But we're going to do this one with 12, 18, and 40. So I want you to take 12, 18, and 40 and find their LCM by prime factorizing all 3 numbers. Go. Get done here. I want you to come up here. So, let's see. Does everybody agree this is correct? 2 times 2 is 4 times 3 is 12? Yeah? I love it. Okay. This one right here, 2 times 3 is 6 times 3 is 18. You guys agree this is correct? Yeah. Great job. Okay. 2 times 2 is 4 times 2 is 8 times 5 is 40. You guys agree that's correct? Yeah. Okay. So it's competition time. Great work. All you guys who did these 3 problems up here, thank you for doing that. Okay. So another thing sometimes I will do when I have more than 2 of these, like 2 times 2 times 3, I'll write it like this. This is kind of interesting. Look what I'm doing here. Okay? Notice what I did. I just lined up all my 2s, all my 3s, all my 5s, so I can clearly see 3 is the winner, 2 is the winner, 1 is the winner. So I have 2 times 2 times 2 times 3 times 3 times 5. Just another way to organize it if you want to. You don't have to. Okay? 2 times 2, everybody help me. 4 times 2, 8 times 3, 24 times 3, 72, 72 times 5, 360. Say woo if you got 360. Woo. Okay, that's impressive. I mean, to be honest with you, we talk about making progress. Okay, to be able to find a least common multiple of 3 numbers, and that least common multiple is as big as 360, and you did that on day 2 of class, I'm not just making you feel good. That's good. That's really good work. Okay, so we're done learning math today. All right, but I got to share a few things with you about Canvas, your assignments, and a little bit about Karate Kid. Karate Kid, what's that got to do with it? You can be done. Thank you.